Hello, in previous video we showed that the distance between two points in a plane geometry, in other words, Euclidean geometry, the distance equals square root of x minus x1 to the second power plus y minus y1 to the second power. And now I want to show you that the equation of a circle is a direct result of a distance formula, which was direct result of Pythagorean theorem. Okay, so notice that any point I pick in this circle, let's say some point right here. Well, the coordinates of this point is some x, comma, some y. And it really doesn't matter where do I pick that point. It could be anywhere on the circle. So using the distance formula, I can claim that the distance between this point x comma y and the center of this circle, okay, so the distance is going to be d equals square root of x minus 0 quantity squared plus y minus 0 quantity squared. And then the next step, I can claim that d equals square root of x minus 0 is just x to the second, okay, plus y minus 0 is y. So I'm going to put y to the 0. Okay. Now, I hope you agree with me that this distance from between these 2 points, in fact, is my radius. So I can exchange this with r equals square root of x to the second plus y to the second. And if I square both sides of this equation, I get r to the second equals x to the second plus y to the second. And by rearranging, I can rewrite this as x squared plus y squared equals r squared, which we know that as equation of a circle whose center is at 0, 0. So how does that help us in here? Okay, well, that's one of the application is the graphing. Suppose I have something like x squared plus y squared equals 1. That means that I have a circle whose radius is 1. So because square root of 1 equals 1. So here's the center. So this is y, this is x, and 1, 1, 1, 1. And then I have a circle with a radius of 1. Okay. How about something like x to the second plus y to the second equals, say, 16. So I know x squared equals x squared plus y squared equals r squared. I know my r squared equals 16, so r must equal 4. And notice I'm not going to be writing plus and minus 4 because radius is always positive. So to graph this one, I go from 0, 0, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and boy, it does not look like a circle because I'm not really good with my tick marks, but if you would please pretend like it's a perfect circle. And what if finally I had something like x to the second plus y to the second equals, let's say this time just 10. Okay, I know r squared equals 10, so radius is square root of 10, which is approximately 3.162. So if I want to graph this one, so 1, 2, 3 is here, 1, 2, -3 is in here, 1, 3, and 1, and 2, and 3, and 0.162 is just a little bit here, and a little bit here, and a little bit here, and here, and there you go. That's your circle. I apologize if my circles are not looking so good. Now here it comes, what if you have a circle whose center is not at the origin? So suppose if you have, let's say that this is my x and this is my y axis. So we have x and this is y. And suppose I have a circle whose graph is somewhere in other than center. So, okay. So notice now that the center right here, the center of the circle is approximately right there. So the position of the horizontal position, it's agreed to call it H. And the position of the height for that point is agreed to call it K. No particular reason for H and K that I know, it's just historically, this is something that we do. And if you pick a point on this circle, no matter where this point is, let's say in here, so this point has the position of x, comma, y. Well, I can use, again, this distance between the center and this point, which is my radius. I can do the same thing again, and using the distance formula, I can claim that d, or the distance, equals x minus h to the second plus y minus k to the second. And we know this distance is the same as my radius. Square both sides. Now I have r squared equals x minus h squared plus y minus k squared. And let me just rearrange that to standard form of x minus h to the second plus y minus k to the second equal r to the second. I need to, well, let me do one example. Suppose I have x plus 2 to the second plus y minus, let's say, 3 to the second equals 9. Okay, so notice that my standard equation for a circle with the origin other than 0, 0 was x minus h to the second plus y minus k to the second equal r to the second. So what does that tell me? That tells me that h equals the opposite of this number, which is -2. K is +3, and r is square root of 9, which is positive 3. So if I want to graph this, I'm going to go so this is my x and my y, -2, positive 3, 1, 2, 3. So here's the circle, the center of the circle at -2, 3. And the radius is 3. So I go 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Now, I'm not doing so good with my tick marks. I apologize for that, but I think you get the idea of this. Let's do one last one, and then I'll do one extra video for you. Suppose I have x plus 1 to the second plus y minus 2 to the second equals 25. Okay, so I know h equals -1, k equals positive 2, and radius equals 5. So here it is. So x and y and -1 and 2. Let me make my tick marks smaller. -1 and positive 2. So here is the center, and I go 5 up. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And here is the graph of this circle. I have to keep this video short, so I will do more examples for you in the next video. Okay, thank you, and I hope you like this video.